We're students at High Science Academy, and our project is about drugs and genetics.
The scientific principle is that everyone has different reactions to the same drug because every human being has a different genetic code, and depending on this code, the drug will react differently. They depend on different types of genes and their alleles. We're going to track down the different types of genes and see how they react to acetaminophen. Next is the ELA component, which is a narrative essay on Janaea. When Janaea was 8 years old, she had a headache, so her mom gave her aspirin. A couple minutes later, she was having trouble breathing and her throat and tonsils were swollen and red. Her mom took her to the hospital to see why she reacted to the aspirin the way she did. It turns out she was allergic to aspirin, but she can take anything with acetaminophen. If she takes aspirin again, she will have to use her EpiPen, or else she could have severe or major side effects.
Tools that were used were a computer internet connection, and then the PharmGKB account, and then the lab journal to write down the results.
So the online account that we used was pharmgkb.com for our PBL. And on the search bar, we searched for the gene acetaminophen since our PBL is about acetaminophen. As you can see, this shows an overview of the drug, and here is the diagram. And it shows the trade names and different names that are used for the drug. And here are other tabs that give more information about the drug. Next is the clinical annotations that were used to define the drug, as you can see on the folder and on the documents as shown below. And these are the various annotations that will be found for the drug or gene acetaminophen. As you can see, there are different descriptions and different variants in genes that are used to find information for each gene. And as you scroll towards the right, you can see more information on how people react to each gene or each variant of acetaminophen. Now we click on the Pathways tab and click on Therapeutic Doses. This shows the description of the drug and how the drug metabolizes in our system. There are different ways on how acetaminophen metabolizes in our system and how it metabolizes, as you can see in the description that's given in the Pathways tab. Now this is the results page, and you can see how acetaminophen reacts to different alleles. Like for example, in the first one, CC, patients with CC genotype may have increased risk of liver failure due to unintentional acetaminophen overdose as compared to patients with CG or genotypes. And as you scroll down, you can see different types of alleles and see how acetaminophen reacts to each one. The real-life connections is that pharmacogenomics promises to offer drug effectiveness, reduce side effects, and provide cost-effective pharmaceutical care. The process of trial and error when exposed to a new drug can be eliminated due to pharmacogenomics. After patients know their genetic codes through pharmacogenomics, they can use this information to update their lifestyles to more healthier and better quality of their health. This also reduces the overall health cost by reducing the number of trials.